This video is on solving two-step equations. So far, we've been solving equations that involve one step, using one of the transformation principles. For instance, I might need to undo multiplication by using division, or I might want to undo addition by using subtraction. In the equations we're going to do now, they involve two stages, or two steps. This means you're going to need to use two of your transformation principles to solve the equation. For my examples, let's say that the unit square is a blue square. Each of the blue squares stands for 1 unit. The red rectangles stand for the variable x, so each red rectangle is the variable x. So let's look at our first problem. I have 1 unit square and 2 x rectangles and 9 unit squares. Now I want to figure out what one of the x rectangles stands for. Now I'm going to start by removing one of the tiles from each side. So I'm going to take this tile and this tile away. Notice that I'm balanced on both sides of my equal sign because I did the same thing on both sides. Now I have 2 x rectangles, so I need to divide what's left over here into 2 groups. Here's one group of 4, and they have to be equal groups, so I'm able to divide what's left into 2 equal groups, or 4 in each group. That means that one of my square or rectangles equals 4. Let's write this out as an equation. I have 1 unit square plus 2 x's equals 9. To start, I used the transformation principle of subtraction for equality, and I took away 1 unit square from each side. That left me with my 2 x rectangles and 8 unit squares. Then I divided both sides by 2 into 2 groups, and I ended up with x equals 4. So notice, I used the transformation principle of division for equality and the transformation principle of subtraction for equality. Also notice that I undid things in the opposite order I would have done them using the rules for order of operations. Let's look at another example. Here again, I have 1 unit square, but 4 rectangles for x, and then I have 5 unit squares. If I take away my unit squares from each side, then I'm left with 4 and 4. So this means that I need to divide what's left into 4 equal groups. There's 4 of them, so there's 1 per group. So this means that 1 rectangle equals 1 unit square. Let's write this out as an equation. I have 4 rectangles plus 1 unit square equals 5 units. I started by taking away 1 unit square from each side, and I ended up with 4x equals 4. That was the transformation principle of subtraction for equality. I divided both sides by 4. That gives me x equals 1, so I use the transformation principle of division for equality. Let's do one more. I have 2 plus 2x equals 8. I'm going to take away these 2, which means I need to take away 2 over here. So I'm subtracting 2 from both sides. Again, I'm undoing in the opposite order I would do. I'm left with 2x equals 6. Now I need to divide both sides by 2. So I need 2 groups. Here's one. Here's the other. They both have the same number in them. And I end up with x equals 3. So I use my transformation principle of subtraction for equality and my transformation principle of division for equality. Now, let's see if we can do this without using our squares and rectangles. Here is a two-step equation. Our goal is to find the value of x. I undo in the opposite order that I would do. So I have addition. I'm going to undo addition first. I'm left with 2x equals, notice here I have a negative 5 minus 9. I need to add the opposite. This will give me negative 14. That was the transformation principle of subtraction for equality. I'm going to divide both sides by 2. This leaves me with x equals, I've got a negative and a positive, so I'm going to get negative 7. So x equals negative 7 is my answer. I used both the principles, the transformation principle of subtraction for equality and the transformation principle of division for equality. Here's another example. Negative 10 equals 6x minus 16. Now, I'm going to DPS this first. I'm adding a negative 16. What's the opposite of that? Well, subtracting negative 16, or adding the opposite. So I'm going to add 16 to both sides. I get 6x equals, a negative and a positive means I subtract 6. I'm going to divide both sides by 6, and I get x equals 1. Alright, now it's your turn. Here are 3 problems using the pictures or the graphics. You need to write out your problem that represents solving for x, and then you need to solve it. So there's 3 of those and 2 of the numerical equations.